All right, guys, here's part 2 of the 2.2 homework numbers 6, 7, and 8. I had to break this up because I realized that I had worded problem number 6 poorly, and if it led me to get an incorrect result, then it might have done or probably would have done the same to you. So if you're in my period 5 class, you all just skip problem number 6, okay? You just skip it. I worded it poorly. But for everyone else, I reworded it to be a bit more understandable, okay? So here we go. Problem number 6, okay? Sally performed an experiment and was able to collect 50.75 grams of product. However, based on the amount of reactants used, she calculated that the reaction should have produced 49.25 grams. So what was her percent error? Now, what makes problem number 6 a bit trickier is that I don't lay out specifically what the experimental value and what the accepted value are. You have to read it and understand it from the statement here. Now, what I'm seeing here is that her experimental, right, she ran an experiment and she got 50.75 grams of product, okay? But when you run an experiment, mistakes happen, okay? Maybe you add the wrong amount of substance, okay? Maybe the substance isn't exactly pure. Maybe you lose some of the substance when you're trying to collect it, okay? So when you run an experiment, that is always the experimental value, okay? However, based on her calculations, she knows that she should have produced 49.25. That's the accepted value, okay? One of the confusing things about percent error is that oftentimes when we're doing chemical reactions, what you calculate, what you predict via mathematical calculations is the correct value. So in this case, all right, in this case right here, the experimental value was 50.75, all right, and the accepted value, the true value, based on her calculations, was 49.25. So let's go run that calculation. Okay, so once again, here is the percent error calculation. It's the true value, which can mean the predicted, the calculated, so forth, minus what you got from the experiment divided by the true value. So the percent error here, the true value was 49.25 minus 50.75 divided by the true value, which is 49.25. We make sure this is an absolute value, all right, because we don't want to get a negative. And we're making sure we're multiplying it by 100. If you hear a crinkling in the background, all right, that's just my cats playing with pipe cleaners. Please excuse that. That's not a microphone error. That is a cat error, okay? So here we go. 49.25 minus 50.75, and that is negative 1.5, but the absolute value signs here make it a positive, okay? So it's 1.5 divided by 49.25. And then we multiply that again by 100, so that we turn it into a percent. So 1.5 divided by 49.25, that is 3.05, or sorry, the decimal is 0.0305, okay? But we multiply it by 100, aka we bounce that decimal point over twice, so 3.05%. 3.05% error, which isn't so bad. That's like 97% correct. All right, so 3.05%. Hey, there we go. All right, great. On to the next one. The Anime Club predicted that their next meeting would require 9.55 liters of soda. Due to a higher turnout, they actually required 10.45 liters. So their guess, all right, what was their percent error? Okay, so the actual value here that they actually needed was 10.45 liters. All right, what they guessed was 9.55. So let's run that experiment now. Let's do these calculations. Okay, so their actual amount was 10.45 liters, okay, minus their guess, all right, which was 9.55, all right, divided by the actual 10.45, okay? And we multiply that again by 100% to get rid of that decimal. So here I go. 10.45 minus 9.55. So the top is going to be 0.9. It's already positive, so we don't need to worry about absolute value. Divided by 10.45. divided by 10.45. All right, and we get 0.0861. Okay, multiply that by 100 to turn that into a percent. All right, bounce that decimal point. So 8.61%. Let's plug that in and see if that's right. 8.61%. Okay, 8.61%. Hey, fantastic. Last one. Last one, guys. The distance between Shania's house and her school is 2.85 kilometers. If she estimated the distance as being 3.15 kilometers, then what was her percent error? Okay, so in this one, the actual distance, the actual value is 2.85. All right, that was the correct value. Okay, she guessed that it was 3.15 kilometers. So that's her experiment, her guess, what she attempted. Okay, so let's run this last calculation right here. Okay, and so because it's the last one, I'm going to write down the equation. All right, percent error equals, all right, the true value minus the experiment, or what you guess, divided by the true value. And again, this top part, we make that an absolute value so that we don't get a negative, and we multiply it by 100 to turn it into a percent. So again, in this case, the actual distance between her house and school is 2.85 kilometers. Okay, so 2.85 minus her guess, which was 3.15, divided by the true value, 2.85. Okay, so how off was she? She was off by, let's see here, 2.85 minus 3.15. She was off by negative 0.3, or since we're just making it positive, she was off by 0.3. 0.3 kilometers was her error, okay? And then we divide that by the true amount, 2.85, all right? And that is 0.105, okay? Now times that by 100% to turn that into a percent. Her error was a 10.5% error. 10.5% error. Let's check and see if that's right. 10.5%. Hey! Okay, fantastic. So there we go, guys. That's walking through this whole homework assignment, okay? Do bonus 1 and bonus 2 for extra credit. I'm not going to walk through them, but if you'd like to do it again, I'll give bonus a piece for each of those. Good luck, everyone.